All right, got another one here from chapter 25. Actually, it's number 1. So let me put chapter 25, number 1. And maybe I'll put page 1. But this one I don't think will take more than 1 page. It says here, calculate the speed of a proton that is accelerated from rest through a potential difference of 120 volts. So this is the part that I was saying that the real key to this problem is about potential. So we want to find this, the change in potential. Because once we get that, then we can find the change in potential energy, which is just multiplying by that charge times the change in potential. And this one's kind of nice because they just give us straight up that this is 120 volts. So the change in potential energy would be the charge. So if we do A here, let me read A. A says, calculate the speed of a proton that has accelerated. All right, so we know that the proton is a charge of 1.602 times 10 to the minus 19 coulombs. And then we know that the potential difference was given at 120, and so this would be, if I grab my calculator here, 1.602 times 10 to the negative 19 for the charge times 120. Comes out to be 1.92 times 10 to the negative 17 joules. So that's the change in the potential energy. Now, I should also point out that that's really a negative change in potential energy. They don't really say that. They just say it's a potential difference of 120. But we know that, let's say this was the potential and the electric field. Let's just say it's from a plate. They don't really say what it's from. But we know the field would go across this way. And so a positive charge like the proton here would go from here to here. It would be a decrease in potential. So that's technically a negative, which then, of course, technically makes that a negative. And they didn't really say that. So that can be a little confusing there. Maybe another way of saying the same thing is we know that the change in kinetic is equal to negative of the change in the potential. But if we just do magnitude, we could just drop the negatives all together. But either way, then, hopefully we are going to write the change in potential then is negative of a negative, and that's 1.92 times 10 to the minus 17 joules. And then that has to equal to the change in kinetic energy. So that would be 1/2 mv final squared minus 1/2 mv initial squared. And then, of course, a real important part here is it says from rest. So that term would be 0 because the initial speed would be 0. And so the only missing piece would be, well, this would be the missing piece, which is they're asking for what is the speed if we put in the mass of the proton. And so the proton has a mass of 1.67 times 10 to the negative 27 kilograms. So if we put that in and do a little calculator work here, so come back to my calculator. Okay, so there's the energy. So times 2, then divided by its mass, 1.67 times 10 to the negative 27. And then take the square roots of all of that. We're looking at a speed of about 1.52 times 10 to the 5 meters per second. And then B really is not much different. B says calculate the speed of the electron that is accelerated through that same potential difference. So if you go back and look what we did, you would see that, potential difference is the same. The charge of the electron is the same. So we're going to get the same change in potential energy, although you might argue that it would go the other way. So the change in potential would be a positive 120. But of course, we would also put in a negative charge here. So we'd still get the same negative change in energy of 1.92 times 10 to the minus 19. And then basically everything would be the same except for right here at the mass. The mass of the electron is 9.11 times 10 to the negative 31.
Sorry.
So if I go ahead then and put in 1.52 times 10, I'm sorry, that's the speed, sorry. Let's go back to the energy. So the energy, 1.92 times 10 to the negative 17. Multiply that by 2. Divide that by 9.11 times 10 to the negative 31. And then take the square root of all of that. 1, 2, 3. 1, 2, 3. 6.49 times 10. 1, 2, 3, 4, 5, 6. Times 10 to the 6th meters per second would be the speed of the electron. All right, so there's A and B.